I slept on myself for way too long. I underestimated the gifts that God gave me for way too long.
Hello, welcome N3 students. Today we're doing N3 lessons and today we're going to be talking about the topic work, energy and power. Let's get into it. What is work? First, work is done when force F is exerted on an object, right? Object and overcome all the work is done when force F is exerted on an object and it overcomes all the resisting forces, right? And then moves in the direction of the force. Okay guys, work is done when force F is exerted on an object and it overcomes all the resisting forces, making it to move in the direction of the applied force. And here is the formula of work. It's going to be F times S, or it's going to be right mass weight. It's going to be weight times height. Know that these are the formulas of work. Work is going to be force times distance and weight times height. So when they ask you to explain what is force, you can say that what is work. You can say that work is the product of force and the distance, or you can say weight is the product of weight times height. Okay, so let's move on. Oh, okay, so it is measured in joules. After finding the answer, its symbol is joules. Right, and now let's move on to energy. Energy is ability to do work. Energy is ability to do work, and we have two types of energy, right? We have kinetic energy, right? We have kinetic energy. This is a symbol of kinetic energy, and the formula is half mv squared, right? Is half mass times velocity squared, and definition is when a body it's when a body is possessed due to the results of movement, right? Energy a body possesses due to its movement. Right? Know that, and we also have potential. EP is going to mgh, right? This one is energy a body possesses due to its movement. So this one is energy definition. Energy a body right, is energy a body possesses due to its height or position above the ground. Right? So energy is ability to do work, and we have two types of energy, which is kinetic energy, and the definition is energy a body possesses due to its movement. And we also have potential energy, which is energy a body possesses due to its height or position above the ground. Here is the formula. It's also measured in joules, just like work. It's also measured in joules. Its symbol is in joules. Last but not least, we have power, and the definition of power according to this topic, because guys, we have power within the topic that talks about electricity, right? And yeah, we have power, even the one that talks about belts. So within this topic, power is the rate at which the rate of work per given time is the rate of work per given time, right? And power is equals to F times S over T. That is the formula, right? So let's move on, guys. So let's talk about law of conservative of energy. Law of conservative of energy. Okay, guys, so energy, E, cannot be destroyed, right? So this energy cannot be destroyed, and again, energy can't be created, right? So energy cannot be destroyed, no, energy cannot be created, but it can be transferred from one form to another. I know that I don't have a beautiful handwriting, but as long as you can see, right? So the law of conservative of energy means that energy cannot be destroyed nor cannot be created, but it can be transferred from one form to another. Okay, cool, guys. Let me show you an example of something. Okay, guys, when there is someone here is that someone holding his ball, and then he drops it. Bam! He drops it. It moves until it hits the ground, right? So where do we find different types of energy? Where do we find energies, right, guys? You see here, it's at the top, right? Kinetic create movement, and movement you can only find it where? In the ground, right? So here we have EK, full EK. We don't have EP. Here we don't have potential energy. Why? Because potential energy happens whereby gravity exists, right? So on the ground, gravity doesn't exist. And here, up here, Gravity exists, so there is no formal movement. So here at the top we have what? We have EP. And here in the middle we have both, because it's about to touch the ground. We have EP and EK, and they are equal here in the middle. Know that, guys. Know that. And I also have a tip. Right? So a tip is when we are dealing with work on an inclined level, right? Here is theta, right? On an inclined level, because you know that objects can move from up to down. Know that here is distance, right? It's distance, right? And here it's height. Know that here it's height, right? And we're gonna use what? Pythagoras. You're gonna use the theorem of Pythagoras. And sometimes they're gonna say this happens within the gradient. They're gonna say m. Remember, in mathematics we call m the gradient. They're going to say it happens within the gradient of 1 to 5, or they're going to say 1 to 5. They're going to say they're going to say 1 to 5, right? Going to say, oh yeah, this box is moving downwards from the gradient of 1 to 5. If they talk about the gradient of 1 to 5, know that it's 10 1 over 5, in which you go to find the angle theta, right? Angle of theta. And guys, this is height, right? So how do we find height? We find height by using Pythagoras. That means this is going to be sine theta, in which height is going to be height over distance. If you are not given distance, you go back and see what you are given. And most of the time, I'm not saying always, I'm saying most of the time, know that this distance comes from your dynamics, right? You know, distance comes from your dynamics. So you know that we're talking about movement. It's whereby we are talking about a squared. Oh, I'm so sorry. A is equals to m s squared, velocity ms, and you know height, which is s measured in meters. Know that it's gonna come from your dynamics. So you must know velocity is distance over time. When you are given, it will all depend on the variables that you are given. Sorry guys, I have allergies, so pardon my voice. You see, forgive my voice. So I want us to move on to the questions, right? This is question number 1. A force 6N, right, gives a mass m and acceleration of 2 meters per second, right? What is the size of, sorry about that, my camera turned off. Okay, as I was saying, we are doing question number 1, right? The force of 6N gives a mass of m and acceleration of 2 meters per second squared. What is the size of m? So let's work it out. Right, guys, so they gave us a force of 6m and they give us a mass of m, right, and acceleration of 2, right? They wanted us to find m. We know that a force is equal to mass times acceleration, and we have 6, we have m, and we have 2. So we divide by 2 on every side. So we have the mass of what? 3 kg. Let's move on to another question. I'm gonna do this one, number 6. A motor car with a mass of 1,200 kg travels at 72. Right, I'm doing this one. travels at 72 kilometers per hour. Calculate the kinetic energy of the motor car, right? So the motor car with a mass of 1,200 travels at 72 kilometers per hour. Calculate the kinetic energy of the motor car. Okay, guys, so a motor car with a mass of 1,200, right? 1,200 kg. So the velocity is 72, right, kilometers per hour, right? And they wanted us to calculate for what? Kinetic energy. They wanted us to right, the mass of 1,200 kg, velocity of 72 kilometers per hour, and they wanted us to calculate for kinetic energy, which this is the formula, right? We have everything we need, but this is not in meters per second. So to turn it, I told you from the dynamics, multiply it by 5 times 18, right? So use your calculators there to transform that into, okay, if you got the answer of 20, you got it right. So it's 20 meters per second. So let's substitute half mass of 1,200, right, times the velocity of 20 squared. EK is going to be what? Use your calculators there. 1,200 times 20 squared. Alright, 1,200 times 20 squared. What did you guys get? Because I got 240,000. Remember, it's measured in joules, right? It's measured in joules. Okay, cool. Let's move on to another question. This one says number 9, right? A 2 kg mass falls 4 meters. Calculate the loss in potential energy. That is the question. It just ends there, right? So the mass is 2 kg. It falls the distance of 4, right? Or the height of 4. Calculate the potential energy. Okay, guys. So they said a ball, right, with a mass 2 kg falls the height of 4 meters, and they want us to calculate the potential energy, right, which EP is equals to mgh, right? So we have a mass of 2, we know gravity is 9,8, gravity is 9,8 times height of 4. It's just like that. You just times everything. 2 times 9,8 times 4. What is the answer? 2 times 9,8 times 4. Get my answer to be 78,4, right? 78,4. It's measured in joules. Okay, let's take a much difficult question. Okay, guys, here question number 26, right? A lorry with a mass 3,200 kg is parked on an incline of 28 degrees, right, with the horizontal. It is then allowed to free from the hill. The friction is ignored and it moved around for like the distance of 0,4 kilometers. So let's write down the given first. A lorry with a mass of 3,200 is parked on an incline of 28 degrees with the horizontal, and then it is allowed to free down the hill. So let's write down the given. Okay, so a lorry of 3,200 kg, right? It's on an incline, right? And they said it's 28. Incline of 28 degrees, right? And here is the lorry is 3,200 again. Inclined, and then they said the distance, right, 0,48 kilometers. So the distance, I told you the distance is from here to here. They said it's 0.48 kilometers, right? So let's see what they want us to do. Okay, so they want us to calculate the speed of the lorry, right? Let's deal with the first question first, ne? Let's not try to confuse yourself by looking at many questions. So let's focus on A first. So they want us to calculate the speed of the lorry. I just want to make sure that I've written down all the given information. A lorry of 3,000 kilometers parked on an incline of 28 degrees with the horizontal. It is then allowed to free down the hill, right? Okay, so it was allowed to free from the hill, but it was what packed. It was parked. It was parked, ne? So that means it was on stand still until it was released. And they want us to calculate the speed after 0.8 kilometers. Okay, so this lorry was parked until it was released. It was on standstill and we have a height. And the moment, guys, we have a height, that means we have gravity is present, right? Know that the moment when we have a height, know that gravity is present. Okay, so it started from this and it went down, right? But it was parked first. That means what had happened, I told you about that example. Something that was here and until it reaches the ground, right? That example that I made, and I said here EP is equal to EK, right? This is very important. So it was parked here. That means it was in the presence of potential. Potential, it was stand still, right? And gravity was present, mgh. They want us to calculate the speed after it went from there to there, right? Okay, guys, so trying to calculate the speed, let's first work on with our potential, because that is the only information we have now. Cannot work with kinetic because we don't have speed. We're about to calculate for it. Okay, cool. So mass is 3,200, right? Times gravity, we know is 9.8, and times height. We don't have a height, right? But how do we calculate the height? I told you, or when I was making this example, right? So to calculate the height, therefore, I'm gonna say sine 28 is equal to height over in kilometers, right? But I want to turn it into meters, so I'm going to multiply it by 1,000. 0.48 times 1,000, because I want it to be in meters. Because remember, when we are calculating speed, remember speed is in meters per second, so we must turn it into meters. Okay, guys, so it's going to be h over 0.48 times 1,000. What is it? What's the answer? I get 480, right? Sine 28. So I'm about to multiply 480 on both sides, which means h is going to be equal to 480 sine 28, right? So work it out for me. 480 sine 28. That is the height. That is how you find. It's 225,35. I'll leave it like that. Now we have height. Height is 225,35. Okay, now we have height, right? So let's substitute our height. Let me just try to wipe, and let's substitute our height here. Okay, so it's going to be 3,200 times 9.8 and times 225,35, right? Times 225,35. Okay, so calculate it for me. I get my answer to be this long answer, right? Get my answer to be 7 0 6 6 8 6 1 comma 5 4, right? Which is what? EP. Okay, guys, from the question, it was said that it was released. That means here in the middle, we have this, what I talked about. In the middle, they are what? They are equal. So what are we going to say? We're going to say EP. Therefore, EP is going to be equal to EK, right? Because it was freed. And here in the middle, they are equal. So EP, which is that long answer, let me just rub it and write it here. Okay, so EP is going to be equal to EK, and that means EK is going to be equal to 7066861, comma 54, right? And we know what is EK. EK is half MV squared, equal to that long answer 66861, comma 54, right? And we have half 0.5 times the mass, which is 3,200, and we are looking for speed, the velocity, right? It's going to be equal to 7, that long answer 70 that long answer 7066861, comma 54, and let's multiply 0.5 times 3,200, 0.5 times 3,200. I get it to be 1,600. V squared is going to be equal to 7066861, comma 54, and V squared is going to be 706686154 divided by 1,600, right? By 1,600. So let's work it out. 66861, comma 54 divided by 1,600, which I get 416, comma 788, right? And we want V, so that means we're going to square root it. So what is the square root of that number? I get my square root to be 6,46 meters per second. So velocity is 66,46 meters per second. So we are done with speed. So let's move on to another question. And now they want us to find the force required to break the brake to bring the lorry to a standstill within 150 meters off on the horizontal, right? So they want us to calculate the force which is required to bring the lorry to a standstill within 150 meters on a horizontal. Okay, cool. So B, right? B. They want us to find the force, guys. Okay, cool. Guys, know that the force is going to be equal to change in energy, right? In energy. It's going to be change in energy divided by distance, right? Force is going to be change in energy divided by distance. So we are looking for force, right? And we have change in energy, right? And the change in energy is 70668 7066861, comma 54, and they said within the distance of 150. So this is how easy it is. It's just change in energy divided by the given distance. 7066861,54 divided by 150. Check it. My answer, my force to be 47112, right, 41, and it's measured in Newton. So that is the end of our lesson. Thank you guys for tuning in. Please subscribe, please share, please tell others about the channel, and let's learn together. Thank you. Have a great time. Bye.